Hello everybody, and welcome to your quick reference guide for the NBM PoWT testbed to which you are a part of. My name is Linda Gilbert, and I am a forecaster from WFO Marquette.
And this is Mike Griesinger, forecaster for the WFO in the Twin Cities, that will be helping Linda with presenting this short introduction to the NBM PoWTs.
So your bottom line up front here. First, what is PoWT? If you didn't already know, it's the probability of weather types. These NBM PoWT grids will be ready to go for you already, but we're going to be introducing some tools that you'll be able to use throughout this testbed period to help you in this process. Remember throughout this testbed that it's all about probabilities. We are moving from a deterministic approach with respect to those weather grids to a probabilistic one, so this may require a bit of a shift in mindset when you're creating and sending out these grids. We're going to be focusing on the ESTF time frame, so that's going to be your 0 to 36 hour time period. But really the bottom line out of all of this is that the concept is to make your job easier as well as providing the best service we can to our clients.
So to answer the question of where will you encounter these PoWT grids in the ForecastBuilder process, the answer is pretty much right away in step 2 when you're updating the rest of the foundation grids. These are foundation grids. If you're in the extended portion, when the extended portion runs 2 times a day, the pot rain, snow, freezing rain, and sleet will all update automatically. So there's nothing you need to do when you're in the extended portion of the forecast. But if you are in that ESTF period, those first 36 hours, you're going to need to select that box next to pot rain, pot snow, pot freezing rain, and pot sleet to update those grids if you want them updated in that ESTF period. And just like our current setup, you can preview what the weather grids will look like before you get too deep into the process. So before you leave step 2, you can run that quick look weather preview NBM PoWT, and you'll see what would result from the weather grids using the current PoWT grids that are in there. And this is what those foundation grids look like, conditional probabilities for each P type. So very basically, we already work with these grids, so it should be something that is familiar to you. It's not introducing anything new. And basically, we take these probabilities in step 6, combine them together to create the final weather grid that right here, where your chances for snow, freezing rain, things like that. We'll spend the rest of this presentation though explaining some tools you'll have available to manipulate the PoWT grids or kind of help you get to the final weather solution that you were wanting to have and thinking that you need to have.
So regardless of whatever method you've been using, this is really just a review and will still hold true for those NBM PoWT grids. The precipitating condition is assumed to be yes everywhere at all times. So what does that mean? An example of this would be 100 pot rain across the entire CONUS in the middle of summer. It's not going to be raining everywhere in the CONUS, but the precipitating condition, or the precipitation type, is assumed to be yes given the precipitation is actually falling. So wherever precipitation is falling, it's going to be rain. And the collective sums potentially being greater than 100, you might have that scenario, and that is okay. Well, what do I mean by that? An example of this would be you've got 70 pot snow, 30 pot rain, 20 pot sleet, and 10 pot freezing rain. Those are all greater than 100, but that's because it's based on the percent chance of that particular precipitation type occurring. There might be times, especially sub-hourly, when you've got these precipitation types that are mixing, as we know that can happen in reality with those transitioning periods and changing weather types. So as we've already alluded to, we've got some tools here to help you in this process. The PoWT limiter, the create time averaging tool, and the shift ZR to snow tool. And we're going to go through these in greater detail, but some of the things I want to highlight out to you right off the bat is with the PoWT limiter, this is really going to help you with that weather key limit issue that I know many of us are familiar with that has been happening in the winter. So this tool will help you with that. Something else I want to make sure I point out to you is that the limiter tool will not change the snow and ice accumulations, but the other two tools will. So make sure that you keep that in mind when you're utilizing these tools. So the first tool, the PoWT limiter, you're going to create and populate this grid at the end of Accum's step number 4. You're going to want to set your value within that grid. You can set it either as a blanket amount across your entire CWA, or you can parse it out geographically and or temporally. Whatever it is that will help you get to where you want to be, you can go ahead and set this grid in advance. And then it limits whatever weather grid you've got below that set threshold. And here's an example of that.
So to just show the limiter in action, we'll just apply a limiter value of 40 across the entire GFE domain here and apply that to those PoWT grids you see on the right. And in particular, we'll look at the impacts of that point highlighted, where you have a 10% chance of rain, 65% chance of snow, and a 25% chance of freezing rain. If you run this tool, to see what happens when you run the tool, on the left is what it looked like before, with that 65% snow, 25% freezing rain resulted in a likely snow, chance freezing rain weather grid. But when you ran the limiter tool with a value of 40, that 25 got ignored. And so now that point just says snow likely. In addition, if you look south of that point in that in the zone of mixed precipitation, you can see after running the limiter tool how much more simplified that weather grid is, where you have that mixed precipitation, and gets into the idea of how we envision that this will help avoid running into the weather key limit issues.
So the next tool, the Create Time Averaging tool, is a standalone one that can be run at the end of Foundation step number 2. And as I've already mentioned, the QPF will be correctly parsed out to snow and ice. And this tool can help address a few things. Number 1, artifacts from limited membership, varying member availability, and lastly, artifacts from interpolation as a result of some of those other issues. So for example, the 1 versus 3 hour availability. You want to make sure that you are collaborating when using this tool. You're going to want to do that with any of your tools, of course, but with this one in particular, when you're using this tool, you want to make sure that you're going to be lining up with your neighbors.
So just to see how this tool works in action, basically what it does is that current hour is what we're going to update, that weather grid, and we update it by simply averaging that current hour, in this case, pot of freezing rain, with the previous hour and the next hour in just a simple average. And when you run that tool, this is what you end up with. On the right is what this looks like after time averaging, and where we've kind of cleaned up the gradients with this pot freezing rain grid are on the west side of the gradient. And these gradients in here were more the result of just artifacts of how we create this grid and the variable members from hour to hour and things like that. But if you look on the east side of this gradient and those sharp gradients you see there, those are all tied to the terrain. So and the topography there of eastern Kansas up through southwest Iowa. So physically, those are a real physical entity that's causing that gradient, and that is retained by the time averaging. But the gradients that are the result of just how we create these grids are smoothed out. So that's the hope of the reason for having this tool, is to kind of help get rid of some of those non-physical gradients that can show up in these grids.
And the last tool, that Shift to ZR to Snow tool, we know this as the big hammer. And this is going to be forcing all of your freezing rain probabilities over to snow. It's really going to be overriding anything that you might see in the prob ice grid, which the prob ice grid is going to be available for you, but is not going to be utilized in this test bed. It doesn't matter whether the freezing rain resulted from like a cloud ice or thermal profile scenario. It gets eliminated entirely. So make sure that you're using this tool intentionally. Here's an example of that. On the left, you've got before, on the right, after, freezing rain on the top, pot snow on the bottom. This tool is great in multiple scenarios, but particularly convectively driven ones. So in the top here, you've got some low-end freezing rain probabilities, and you're thinking that that might not come to fruition. So you run this tool, and the end result is it'll tick upwards your pot snow grid, and that's what you see on the bottom right there. So you can use this in a wide variety of situations, but mostly those convectively driven scenarios, such as LES environments, so great for the Great Lakes and surrounding offices. You're going to really want to use this with caution in any synoptically driven type scenarios. So we've identified some potentially problematic weather scenarios, things that you might want to pay a little bit extra closer attention to when you're doing your NBM PoWT grids, and where these tools can help you in this process. So instances where cloud ice could present issues, such as convective environments, as I've already mentioned with LES, or steep lapse rates with strong cold air advection. Precipitation onset with a very dry antecedent environment. You may see this issue arise when there are timing differences in model solutions. So for example, some models might be dry aloft and may depict some freezing rain, whereas others could be saturated with precipitation and depict snow. Back edge of a precipitation shield associated with a departing mid-latitude cyclone. Systems where winter weather probabilities can be more borderline. So this might be your early or late season systems with multiple weather types that are changing rapidly. And then in the mountains, strong cold advection that leads to rapidly falling snow levels.
And finally, they're just using the tools to help you. It's our hope with this test bed that the most efficient approach and the most useful tool you'll have is that PoWT limiter tool. Start there, and hopefully that'll do most of what you're hoping to do without having to go in and manually manipulate any of the grids or anything like that. But yeah, start with that PoWT tool. Remember, you know, especially in a convective environment, you have the option to just push any freezing rain probabilities to snow. And finally, and if and only if there is kind of a fail safe, if all else fails, you can revert back to the legacy method there in the when you're creating the weather grids and accumulations in step 4. When this box pops up, it's going to default to using the current PoWT grids. But if you tried the limiter and you don't like what's happened, you've manipulated some of the grids and you just can't get things, it's still not getting to where you want it to be, you do have that emergency escape hatch there where you can go back to using the legacy top-down procedure to create your weather grids. But again, we say this is the last option. If you use it, please provide feedback of why you did and screenshots for maybe where things weren't working out.
All right, so kind of wrapping things up here, what we need from you within these testbed offices. Cannot stress it enough, feedback, both good and bad. You had a great scenario from the NBM PoWT grids? Great, let us know. You had something that didn't work out so well? We need to know that too. So don't be afraid to experiment, but again, just let us know what did and did not work. It'll help us all out in finding out what is going to be the best approach moving forward. We've got some additional resources here available for you. The first link here is to a presentation that is going to be given live, and it goes into much greater depth, and highly recommend that you check out that presentation when it is ready to go online. And the next link here is information for the test bed. You're going to be utilizing this for your resources. And those last two links there, your NBM web viewers. This is great for both teleworkers and those in the office. You could find some great information either by point or that plan view by clicking on those links there. And we'll have this presentation available for you to click on those links. So if you've got any questions, comments, feedback, whatever it is that you want to let us know, go ahead and send us an email at that email address there, and we will get back to you as quickly as we can. Thank you guys so much for tuning in, and good luck this winter.